Okay, let's talk a little bit about counters and what counters do. So, not surprisingly, they count. They don't always count the same way, and they don't always count in the way you would expect them to, but in general, they do. And so you can talk about a 3-bit counter or a 4-bit counter, and you can talk about an up counter, or you can talk about a down counter, and you can make counters with T flip-flops, and you can make counters with D flip-flops, and if you look in your book, you have examples of all of those. But let's just talk, I'll start with a 4-bit counter. So a 4-bit counter means that you have 4 bits, and if it's an up counter, that means that you are counting up. So this is 0, the next going up would be 1, and then 2, and then 3, and then 4, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then we go back to 0, 0, 0, and then 0, 0, 0, 1, 0, 0, 1, 0, and so forth. So that would be an up counter. One thing that you may notice is what happens is, it's easiest to see, let's look here. A bit will flip from 0 to 1 when all the bits after it are 1. And so here I have a 0. It's going to flip to 1 when all the bits after it are 1s. So all the bits after it here are 1s, and so it flips from 0 to 1, and all of those 1s turn to 0s. Okay, when we get to the next one here, there's nothing that has all 1s after it, and so the final bit flips from 0 to 1. Now, when we're on this one, this bit has all 1s after it, so it flips from 0 to 1, and all the ones that were after it go to 0. Okay, so it's now here. Now this bit has all 1s after it, so it flips from 0 to 1, and these go to 0. Well, now we don't have any bits that have all 1s after it, so the final bit flips from 0 to 1, and now this bit is the only one with all 1s after it, so it flips from 0 to 1, and the 1s after it change to 0. Now, if we look in this one, there are no bits that have all 1s after them, so the final bit flips from 0 to 1. And now, if we look here, they're all 1s, and so they all flip to 0. So that's an up counter. A down counter, as you might expect, counts down. So if we started at 1, 1, 1, 1, our next one would be 1, 1, 1, 0, and then it's harder for me to count down. So that's 15, 14, so we want 13, so that'd be 1, 1, 0, 1, and then 1, 1, 0, 0, and then 1, 0, 1, 1. Let me make sure I have these right, so that's 15, 14, 13, 12, 8 and 2 is 11, yep. Okay, and so the next one after that would be 10, so that would be 1, 0, 1, 0, and then we have 9, that'd be 1, 0, 0, 1, and then 8, 1, 0, 0, 0, so that is a down counter. And of course, when we get all the way down to 0, 0, 0, 0, the next one after that would be 1, 1, 1, 1. So I have never actually thought about this for a down counter, but let's see, it probably works exactly the opposite as an up counter, as you're looking for when a bit has all zeros after it, it flips from 1 to 0. So this one, there are no bits with all zeros after them, so the final bit flips from 1 to 0. Now this bit has all zeros after it, so it flips from 1 to 0, and the zeros after it flip to 1. Now in this one, there are no bits with all zeros after them, so the final bit flips from 1 to 0. Now on this bit, this one, this bit has all zeros after it, so it flips from 1 to 0, and the zeros flip to 1, and so forth. So that's how the counters work. Now here we have some counters made with T flip-flops, and let's take a look at how they work. I will start with which one is on your homework. Your homework has a down counter, so I will do the up counter. Okay, so let's take a look at the up counter. So if you look at the up counter, well, let's before we do that, let's take a look at what the difference between the up counter and the down counters are. So if you look at the down counter has the output from Q going into the clock, and the up counter has the output from Q bar going into the clock. Now why would it go into the clock? So going into the clock, when the clock is 0, when the clock does not have a positive edge, then it's when the flip-flop does not have a positive, when the clock on the flip-flop does not have a positive edge, it's not going to do anything. Which one did I say I was going to do? The up counter. Okay, so let's take a look at this up counter. And let's say we are starting at 0, 0, 0. So what that means is Q0 is 0, Q1 is 0, and Q2 is 0. Well, what does that mean Q0 bar is? Q0 bar is 1, Q1 bar is 1, and Q2 bar is 1. So the input into all of these flip-flops, the T is 1. So it's 1 into all the flip-flops. Let's remind ourselves of how a T flip-flop works. So the way a T flip-flop works is, here's your input T. Here is your old value of Q. And then here is your new value of Q. First of all, if the clock is 0, there's no change. It is also true that if T is 0, there is no change. So if T is 0 and Q old is 0, Q new will still be 0. If T is 0 and Q old is 1, Q new will still be 1. So that means Q doesn't change if T is 0. Now if Q is 1, that means when you have the positive edge of the clock, then you have a toggle. So if T is 1 and Q old is 0, Q new will be 1. And if T is 1 and Q old is 1, then Q new will be 0. So what that means is when T is 0, there's no change, or when the clock is not at a positive edge, there's no change. And when T is 1, you have a toggle. So what does it mean to be at a positive edge? So a positive edge means that you are going from 0 to 1. Alright, so we are starting at 0, 0, 0. And then we have our first clock positive edge. Now notice that our input into all of the clocks, well, into the clocks for Q1 and Q2 is 1, and so it is not going from 0 to 1 for the clock. And so Q1 and Q2 are not at a positive edge. Q0 will be at a positive edge because it actually is at the clock positive edge. So when you have the clock positive edge at the first clock positive edge, Q0, so the input is 1. Input is 1, so that means as long as the clock is at a positive edge, it'll toggle. So that means Q0 becomes 1. That means Q0 bar becomes 0. But Q1 doesn't change because its input to the clock is Q bar. And Q bar did not go from a 0 to a 1. So it doesn't change, and this doesn't change, and the same is true with Q2. It also doesn't change because its input is Q bar from Q1, and it did not go to a positive edge. So on our next clock positive edge, Q0 is always going to toggle on a positive edge because its input is 1, its clock is the clock, and so on every positive edge it'll toggle. So 0 will go to 1, 1 will go to 0, and Q0 bar will also toggle. Okay, so now let's take a look. Okay, but now look at what happened for Q0 bar. It went from 0 to 1. So it went from low to high. It went from low to high, and that's the input into the clock for flip-flop 1 here, Q1. So its clock got a positive edge. So its clock got a positive edge. Its input is T, and so its input is 1, and so it will toggle. So it will go from 0 to 1, and Q1 bar will go from 1 to 0. Well, now let's look at Q2. Its clock input is Q bar from the one before. Did it have a positive edge? It did not. It went from high to low. And so since it did not have a positive edge, it will not change. Okay, now the next one, this one will always toggle because its clock is the clock, so it will toggle 1, and this will be 0. And now the next one, from 1 to 0, that is not a clock positive edge, so it is not going to change. So if you look at Q2, this is its input into its clock. It did not have a positive edge, so it will not change. Okay, on the next clock cycle, when we have a positive edge, this one will toggle. This one now had a positive edge, so it will toggle. And now this one will see a positive edge. So 0 went to 1, it'll have a positive edge, so now it will toggle. And so let's see what our output was here. We started with 0, 0, 0. And our next one, well, let's write it in this order: Q2, Q1, Q0. So 0, 0, 0. And then the next time around, Q0 was 1, Q1 and Q2 were still 0. the next time around, Q0 was 0, Q1 was 1, but Q2 was still 0. The next time around, Q0 was 1, Q1 was 1, and Q2 was still 0. And then the next time around, Q0 was 0, Q1 was 0, and Q2 was 1. So what did we do? This is 0, 0, 0, that's binary 0, 0, 0, 1, that's binary 1, 0, 1, 0, that's binary 2, 0, 1, 1, that's binary 3, 1, 0, 0, that's binary 4. Indeed, we have an up counter. And the way it's working is the way I described that it would work with, you'll have the bit flipping from 0 to 1 when all of the bits after it are 1, and that's a consequence of the way the circuit is set up. Okay, so now let's take a look at the down counter. Now this is the one that's on your homework, so I'm not going to start it where your homework starts, but we'll start it somewhere else. Where did it go? Here's our down counter, and so I will have, this is Q0, Q1, Q2, so Q0, Q1, Q2, and let's start it just somewhere random. Let's start it at 1, 1, 0. So keep in mind that when we write that with the most significant bit first, that's 0, 1, 1, so that's the number 3. So we would expect the next number to be 0, 1, 0. Okay, so let's look at what happens. This time we don't need Q bar because our input into the clock is just Q. So when we have, and we know that the one that was right before this was, this is a down counter, so the one right before this was 4. Wait, hold on. That's 4 would look like this. Okay, so now Q0 has its input as a clock, and so we're starting its input as a clock, and the clock is the clock, and 1 is its input for T. That means as long as the clock has a positive edge, it will toggle, and so Q0 is always going to toggle. So it will always go from 1 to 0 to 1 to 0 every time. Now let's go to Q1. So Q1, did its clock have a positive edge? It did not. It went from 1 to 0. Since it did not have a positive edge, it will not toggle. Did Q2, did its clock have a positive edge? Well, its input is Q1. It went from 1 to 1. That's not a positive edge. There's no change there. That's 0. Alright, so now on the next one, for Q1, did its clock have a positive edge? Yes, Q0 went from 0 to 1, so it will toggle. It'll be 0. Q2, did it have a positive edge? No, Q1 went from 1 to 0, and from 1 to 0, that's not a positive edge, that's a negative edge, so it won't do anything. Now do we have, on our next one, do we have a positive edge? No, it's going from 1 to 0, that's a negative edge, so that will stay 0. Did this have a positive edge? No, 0 to 0 is not a positive edge. So let's go one more. Let's say we have 1 here. Did this have a positive edge? Yes. So this will be 1. Did this have a positive edge? Yes. So this will be 1. Okay, well let's take a look at these numbers we got here. Remember, they're written in reverse order. So we have 0, 1, 0. So the next one is 0, 0, 1. The next one is 0, 0, 0. And the next one is 1, 1, 1. Is this what we would expect? Yes, because this is the value for 3, 2, 1, 0, and then you go back around to 7.